In this video, I'm going to present a mnemonic device that will help you memorize both glycolysis and gluconeogenesis. You're going to start by setting up your page as such. You're going to put the numbers 1 through 11, including 10.5 between 10 and 11, straight down the center of the page, skipping one line in between each number. So we're going to start like so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget 10.5. And 11. Then in the interstice between each of the numbers in a different colored ink, we're going to use purple for the glycolysis side. You'll see what I mean in a second. You're going to put the letters A through J, like so. A, B, C, D, E, F, G, H, I, J. And J can actually, it goes here, but it's really between 10 and 11. You don't really use J, you don't really use 10.5 on the glycolysis side. You're going to do the same for the gluconeogenesis side, which you'll see in a second, except we're going to do it this time on the left side, and we're going to start by saying A, B, C, D, E, F, G, H, I, J, and then K between 10.5 and 11, like so. And like I said, this is the gluconeogenesis side, and the purple side is the glycolysis side. Okay, so let's start with the states or the different compounds that come between glucose and pyruvate, which are both 1 and 11 respectively on this chart. The mnemonic that you need to know is good guys finish first, dim guys by third place, second place, phosphoenolpyruvate, skip 10.5 because that's for the gluconeogenesis side, pyruvate. So start by filling that in. Good guys finish first, dim guys by third place, second place, PEP, you get that one for free, and pyruvate. You also get that one for free. Okay, so let's start with the top. We know that this all starts with glucose. Then we know that it goes to glucose 6-phosphate. Then we know that it goes to fructose 6-phosphate. Then we know that we add another phosphate group, so it becomes fructose 1,6-bisphosphate. Then we get this weird one, which is dihydroxy acetone phosphate, followed by the one that everybody wants, which is the glyceraldehyde 3-phosphate. Okay. Then comes the B is kind of a misnomer here. It's actually just kind of reminding you that the next thing that comes is actually a biphosphoglycerate, but it's actually 1,3-biphosphoglycerate. Then the 3 you get for free is you just add a phosphoglycerate to this. Here you get a phosphoglycerate again. You get this one for free. And then you have to remember that you get the PEP and the pyruvate for free. Okay, so we finished all the different states. Now in purple ink, we are going to go through all of the different enzymes that are used on the glycolysis side. And for that, we have a nifty mnemonic as well. That one goes like this. Happy people, please assholes. So HPPA. Those glad people pleasers eat pie. TGPPEP. We start with the top. Hexokinase. Followed by phosphoglucokinase. Oh, sorry, phosphoglucoisomerase. Getting ahead of myself. The next is phosphofructokinase, followed by the aldolase, which is a lyase, followed by triose phosphatase, isomerase, I feel like my purple pen is giving up here. Okay, see if that worked. Followed by glyceraldehyde, phosphate. I'm not going to write that all out because the important thing to remember, this is an enzyme and it's dehydrogenase. Okay. The next thing is a P, and this one kind of you get for free too. This is phosphoglycerokinase. Followed by phosphoglyceromutase, which you also kind of get for free. You get one, you get the other. Glyceromutase. All right, I'm going to switch pens here or something. I don't want to confuse you guys, so I'm going to switch to this light blue. Okay, followed by enolase. And finally, the P, you also get this one for free, is obviously pyruvate kinase. Okay. Now we head over to the other side, and we're going to do that in our blue pen, wherever that went. Here it is. And we're going to remember that all of the enzymes for the glycolysis side are the same on the gluconeogenesis side, with the exceptions of the ones that occupy the positions that fit this mnemonic. Always carry joules, kids. So the ones that are different are, you can put a little arrow, A, C, J, wherever J is, down here, and K. Always carry joules, kids. And the mnemonic to remember there, for what those ones start with, goes like this. Good for people pleasers. And the mnemonic to remember there is good for people pleasers. So you're going to put a G for people pleasers. And you're going to start, this one here you get for free. Make sure this thing is focused. Okay. This one here you get for free. This one is glucose 6-phosphatase. So you just look down at your step 2 here, which is glucose 6-phosphate, and you can put it right there. Glucose 6-phosphatase. F here you also get for free by looking down. Fructose 1,6-biphosphate is changed to fructose 1,6-biphosphatase. So fructose -1, 6 biphosphatase. J, you don't really get for free. You have to look that it's a PEP carboxykinase. And the only way to remember that is that it's close to PEP. And on this side, I guess you can think about it as going up instead of down. So J actually gets PEP, which remember stands for phosphoenol pyruvate. PEP carboxykinase. And then K starts with the P, and we can remember this just as pyruvate carboxylase, right? Because it comes before that. So I guess a good way to remember this is for the top 2, you look down, and for the bottom 2, you look up, and for K, the up that you're looking at is really just J. So this one is pyruvate carboxylase. Okay, now one thing that we haven't put down here is what occupies the space at 10.5. There's really no good way to memorize this other than the fact that you just memorize it straight out, and it's oxaloacetate. And you're going to see why this all kind of makes sense, why I put it together this way in a second. Okay, so now we have our entire list. Remember, these are not really blank. They just happen to be the same as the ones in purple on the other side. Okay, so in my orange pen now, I'm going to go through and I'm going to explain which ones get these arrows on the glycolysis side. And the arrows just mean electron carriers or an ATP or ADP turning into an ATP or vice versa. So the thing to remember is that you don't want to get out of bed. Bed spelled like you're an idiot, so B-E-H-D. So the letters B-E-H-D, you don't want to get out of bed. So you're going to skip B, E, H, and D for this. So every letter aside from B, E, H, and D gets an arrow that looks like this. So that's B, so it doesn't get one. C is not B, E, H, or D. D is in that. E is in that. F gets one, not in that. G gets one, not in that. H is in it, doesn't get one. I is not in it, gets one. J is in it, is not in it, and gets one. In the beginning, it takes energy. ATP in, ADP out. Same thing for C here. ATP in, ADP out. Sorry that I'm kind of writing on top of myself here, but when you're doing it up for your own or whatever, you'll make more sense of it than I'm making here on this video. F is the only confusing one, and I always write the coefficients 2 when I'm doing this because I know that secretly the dihydroxyacetone phosphate through the enzyme triose phosphate isomerase becomes a G3P or glyceraldehyde 3 phosphate. So it's really happening twice, and this is really just between 5 and 6. E is just making sure that conformation 5 is the same as conformation 6 so that it can proceed with the rest of the glycolysis. So to get back to what's happening here around F, you have 2 NAD pluses plus 2 inorganic phosphates make 2 NADHs plus 2 H pluses. Then for G, now we start getting energy out. So we put in 2 ADP and we get out 2 ATP, which is what we're here for. The enolase, you're going to have to remember enolase is a lyase and water comes out of it for whatever reason. So this guy, you're just writing there's a water. Nothing in, just out comes H2O. Then the pyruvate kinase, 2 ADP go in and 2 ATP come out. So we're going to look at this and just notice a couple of things here. Make sure that's all in focus. Okay, great. Whenever you see the word kinase, ATP goes to ADP or vice versa. Phosphofructokinase, ATP to ADP. Then we're going to work down here. Phosphoglycerokinase, 2 ADP go to 2 ATP. Pyruvate kinase, 2 ADP to 2 ATP. So if you see the word kinase, it's a good chance that an ATP or an ADP is switching with one or the other. Some of these are named for the backwards reaction, so I'm not going to tell you that it's always that way to confuse you, but for this list, if there's kinase in it, you know you should be doing something with ATP. Okay, now to go to the other side. The other side, again, is more or less the same with the one funky thing that has to happen here, obviously, because we have a couple more things going on down here with the whole addition of this K and the 10.5 and the yada, yada, yada. So to start up here, right, we know that we're doing the opposite as we were doing on the glycolysis side. So an inorganic phosphate comes out and an H2O comes in. That's how we break these things, right? We add a water, the water hydrolyzes a bond, and the inorganic phosphate falls out of the ATP. Okay. Around C, it's a similar story. An inorganic phosphate comes out and an H2O goes in. And notice how the heads of these arrows are heading in the opposite direction, because in gluconeogenesis, we're working from the top, from the bottom, and going to the top. Whereas on glycolysis, we were working from the top and going to the bottom. Okay. D and E are left alone. F is exactly the opposite of the F on the other side, so you get that one for free. You just have to memorize it one time, and you're going to get NAD plus at the top, plus 2 organic phosphates. And with the addition of NADH plus 2 H pluses. Around G, it's the exact opposite story of the other G, so you're going to get 2 ADP out for 2 ATP in. Notice again the arrows in the opposite direction, all of these arrows in the opposite direction. And then you're going to go to the enolase, nothing happens here. The PEB carboxykinase, this guy is weird. CO2 plus GDP and GTP goes in. These also should have a 2 in front of them. Okay. Now, K is also strange in that, lost the camera there for a moment. K is also strange in that you put in 2 ATP plus 2 CO2, and you get out 2 inorganic phosphates plus 2 ADP molecules. Okay, so now we're pretty much done for all the content of this. The only thing left to remember is in this red pen, I'm going to go through and explain what's going on here with the 10, 10.5, 11, and the J and the K. Okay. So, pyruvate has to go through pyruvate carboxylase first. Then, when it goes through the pyruvate carboxylase, it becomes oxaloacetate. The oxaloacetate has to go through the PEP carboxykinase, which then becomes PEP. So that looks, I think, more complicated than it is or whatever, but it's really not that bad. Then the other thing to remember here is that when you're actually going through and using this on your exam, as your like cheat sheet or whatever, you scribble this back on of some equation sheet that they give you or whatever, you have to remember that when you're going down, you skip going down. And by going down, I mean going down through glycolysis you skip the 10.5 oxaloacetate. It's not present. Okay, I hope that makes sense, and I hope some of you guys can get something from that.